Brilliant. Okay, thank you all for coming today. Welcome to another Argo Workflows and Events community meeting. We're going to do a slightly different format today, and I'll tell you a little bit about that shortly. But what's on our agenda today? So we're going to be talking a little bit about some CNCF stuff. We've got Tihomir from the Serverless working group who's come here to talk a little bit about what he's doing, and I'll explain that shortly. Just a brief, any questions anybody wants to ask about the Slack migration, today's a really good time to bring those up, and we'll be pushing you to move over to the CNCF Slack. I'll talk about that shortly. And then I've got two, I guess, pretty relatively short discussions around some upcoming new features. One is called template defaults, which is, I'll let Bala tell you a little bit more about that. And a large kind of interesting feature we're building out to help specifically improve our support for Kubeflow pipelines. And hopefully we'll get a discussion from KFP. They'll be able to come along soon to one of these community meetings to talk a little bit about that. And Bala will also be doing that shortly. And of course, there's any topics you want to bring up or any discussions, you can bring that up during the course of today. So do just add yourself to the attendees. Let us know where you're from, maybe even what you're doing with Argo workflows or Argo events. I'm going to assume that everybody here is familiar with Argo workflows events, so I won't go over that today. Just a little bit about myself and a couple of the other engineers here today. Myself, Bala, Jesse are all, and I'm thinking Simon and Derek are probably here, are all core engineers from the Argo teams working on Argo CD, Argo rollouts, Argo events, and so forth. So if you want to ask any questions, we're here to talk about that. Now, if you do want to ask any questions, the best way is probably just to ask at the end of a presentation when somebody's finished. You can probably just ask out loud then, or you can drop a message into the chat room of this Zoom meeting and somebody will read out your message, or you can come back if you want to ask more details. You can come and ask us on the Slack channels later on. People always ask, and I always say, yes, we are recording this. Where does the recording end up? Well, it typically gets uploaded to YouTube, maybe later today or tomorrow, depends on how long the processing takes. And then I'll share that link to that video in the Slack channels again. Talking a lot about Slack today. So any questions before we get started? Brilliant, silence. Okay, Tihomir, can I pass this over to you?
Yeah.
Brilliant.
If I can share my screen. Can you see it? All right. So first of all, hello, everybody. I really like to thank Alex and the whole Argo team for having me here and talking about our little CNCF project. Just as a little background, my name is Tihomir, and I'm one of the maintainers of the Serverless Workflows Specification Project. I've done this talk a little bit, or kind of introduction, long time ago, but a lot of things have changed since then. And you know, thank you again, everybody, for giving us the opportunity to have this little chat. So just to get started, it's kind of hard to talk about our project without talking about workflows, and I know Argo is also in this area as well. But the way I want to start it off is there's a bunch of different definitions of what a workflow is, and there's just as many workflow technologies currently that have different definitions. Just from my personal perspective, when I look at workflows, I think of them as resilient programs, and I'll try to explain that. With workflows, we want to really focus on what and nothing else. So we write our workflows typically thinking of our code or the way we describe workflows as things that are relevant to our business, such as requirements, logic, whatever we think that represents our business. That's how we want to write it, and really only want to focus on that. But reality of things, as we all know, is quite different. Once you start creating your applications and you start writing your business requirements in code or in a DSL or whatever you have it, soon you realize it's not ready for production. And to have production ready code, you have to think about failure, recovery, persistence, and a whole bunch of different things. So once you start mixing up your business requirement and logic with all these other non-functional requirements that are required for you to have a production application that you want to deploy and have your customers actually use it, you create complexity, right? So this is kind of the basic premise of why workflows I think of as resilient programs, really. So when we started looking at workflow solutions, we have two things. We have some sort of workflow definition or some sort of representation of our logic and our requirements that we can that we have to define. You know, unfortunately, we can't do this in our natural language. And if anybody's here from like Google or Microsoft, you know, you guys might be already working on that type of feature, but it doesn't exist yet that I know of. So we define usually our workflows in different ways. And on this other side, we have a workflow runtime, which is some different workflow engines that actually know how to interpret the instruction and that we define our definitions and know how to execute them. There are typically a number of types of things that workflow definitions and workflow runtimes are kind of responsible for in workflow technologies. Looking at the definition itself, most of the time they're written in a deterministic manner, meaning that given a set of inputs, whether they be data or some sort of signals or messages, we expect our workflows to produce an expected output. The second thing is idempotency, meaning that if you run this workflow once or 1,000 times, given the same input, you would expect some sort of output that is the same. Now, workflow definitions usually define, we put in a series of instructions or decisions that we want to execute that define, again, our logic that we want to implement. And our workflow definitions typically have some features like reacting to events and stuff like that. On the other hand, is really the workflow runtimes, which you guys are also dealing with at Argo, is that provides the resilience part. And the list of those things is not kind of like a list that every workflow runtime has to implement or does implement. It's just some things I put on the other side. Things like, of course, execution. We want to provide insight to our workflows, such as visibility in both design, testing, and also the runtime visibility. And I think Argo does that very well. Things like isolation of workflow instances, fault tolerance, scalability, timers, persistence, all those things are typically responsibilities of workflow runtimes that really bring the resilient part to our workflows. Now, well, I forgot to say one thing. When we, for our serverless workflow specification or project, we really deal only with workflow definitions. We're not dealing with a workflow runtime, and we'll leave that up to like experts like the Argo guys and everybody else. So dealing with the workflow definition, we currently can define our workflows in many different languages, and they typically fall into 4 different buckets, in my opinion. One is the flowchart-based type of languages, the form-based, declarative types of workflow languages, and also there's a lot of workflow languages that they're defined as in programming language construct. And again, with our little project, we fall kind of, I think, in the same category as Argo for workflow being declarative workflow languages. So now let's take a look at some of the features of declarative workflow languages. Nowadays, they're typically described in JSON or YAML format. That's kind of like becoming the standard. And they don't depend on visualization. However, they're defined in some sort of machine or human readable format. So typically declarative workflow languages do use some type of expression language for different things, typically manipulating the workflow data or the state of things during workflow execution. Now, declarative workflow languages are typically focused on smaller scale orchestrations because, I mean, let's be honest, who wants to look at a 2,000 lines long YAML or JSON file? And because of that, they typically focus on a specific domain. And just like, flowchart based and form based and also declarative, these types of workflow languages are translated into some sort of executable code that can be executed, of course, on different types of environments. When we look at the workflow or the domain for our serverless workflow project, it is specific to microservices events orchestration. So our DSL or our workflow language focuses on things like dealing with events, dealing with execution of the functions, things like, so focusing on microservice, distributed systems, and those types of architectures. Now, what is specific a little bit about the serverless workflow DSL? You can define it in both JSON and or YAML formats. So either or, both are equivalently supported. The DSL can be implemented on runtimes as a state machine or a DAG. And even though we do allow kind of cyclic or cycles within the DSL, we can break out of them using things like timers and stuff like that. Timers on execution side and other kind of timers as well. With the DSL, you can describe both stateless and stateful orchestration or execution of your workflows. Another thing that maybe our project is a little bit or what we focus on is the workflow definition. We try to structure it into three distinct or separate parts. The first one, of course, being the control flow logic, and that is typically the decisions that you want to make during your workflow execution, and that includes a lot of different things like looping, database decision, async execution, waits, things like undoing things or compensation types of handling and things like that. So that allows us to translate our business requirements into some sort of decision flow that we want the runtime engines to actually execute. The other two parts deal with events and function definitions. Event definitions being a reusable set of definitions of the types of events that you want either to consume or produce during workflow execution. And you can, we of course use cloud events for that. I failed to mention we're part of the serverless working group at CNCF. So we are kind of, related to also cloud events project as well. But event definitions basically allow you to hook to any sort of producers or consumers of events and then be able to interact with them. The third thing is our function definitions. That section is also reusable. Reusable meaning it can be reused between multiple workflow definitions. And those help us define our invocations of different services. And that being either REST services or any kind of services, they being container or even images, kind of like I think what Argo is very good at as well. I'm not going to go much more into this language. If you're interested, we do have a poster available on our website. So you just go to serverlessworkflow.io /poster. And this image, you can go through and see all the different things that or constructs that the DSL provides. So I like this. I really want to ask the question, and a lot of people ask, so what's the point of having this serverless workflow language? I like to be realistic, honestly. And right now, or I've been working for this for over 2 years now. And the reality of things is that honestly, at the bottom line, it's an open source, vendor neutral, community driven alternative to AWS Step Functions and Google Cloud Workflow. And I think this is kind of like, this year has been really good for us. We've received a lot of community type of interest. And I think it boils down to maybe this. We don't use this as a marketing strategy, by the way, just to letting you know. But it is kind of like a realistic expectations that for people they're interested in our language at this time. But what makes serverless workflow different than some of the other things that we looked at? Well, one of the things also is we focus on standards. So like I said, we have native integration and we kind of enforce these standards as well. So things like cloud events for event definitions, Open API and gRPC, for function invocations. Async API is kind of like the thing that we're currently working on. And even though we do allow multiple expression languages to be used and they're user defined, we do default to JQ currently. And basically everything that we add to the language, we try to associate it with some sort of current standard, of course, within the technology domain that we're targeting. So what about functionality? And I usually use this type of table and with some of the comparison. And I usually, here you'll see step functions, Google Cloud, BPMN is even being a huge standard. And then I tried to compare it with serverless workflow. And this table, as you can see, it really doesn't include everything. And trying to focus on some of the functionality that is relevant to our microservice orchestration. So things like retries, compensation, execution, parallels, async invocations, and things like that. And so far, the way kind of our DSL fits in there, of course, it's currently a superset of step functions and the cloud workflow, but it is by far a small subset of course, the BPMN specification. So we kind of fit in there in the middle. Why else do people look at our specification for? Well, one of the things and is really, it's easy to build a kind of common experience that people are seeing for these types of workflows. And we're going to look at that even at the demo, but we have a little ecosystem around. So we just don't specify the DSL currently or the definition of our workflow language, but we have a little ecosystem around that as well. All right, what about SDKs? We do have SDKs in Java, Go. Those we've had since even, I think the last time I had the opportunity to talk with you guys, but since then we also added .NET and TypeScript that we're working on currently as well. And our SDKs is not really runtime implementations. They're more of a SDKs for parsing the workflow language structure into an object model, and then pushing it back if needed into the DSL markup language. So next, the question that we usually get, hey, who's using this thing? And this slide right here, it's kind of an underrepresentation. It's kind of hard even now to kind of get an approval of everybody who's using it. I think, if you guys join the community, I think a lot of the things you will see that it's probably much bigger than what the slide says, but we do have collaborations with different projects, such as cloud events, of course, Argo being one of the top ones for us. And also we're collaborating currently with the Tremor projects as well at CNCF. As far as community collaboration, we do have a number of companies that are looking at us. They're evaluating, some are working on some implementations already. But like I said, it's hopefully by KubeCon NA, we will be able to expand this list and make it much bigger. As far as open source implementations, we currently have 2 Java-based implementations. And you can Google those and then figure out, but there's a lot more in the works as we are currently at this time. So as far as our roadmap, we last month released our version 0.6 of the specification, and each one of our releases goes alongside with the releases of our SDKs, our VS Code plugin, our diagram generation things, and basically we try to release everything at the same time. But from the specification DSL perspective, we release 0.6. We're looking at July release of 07. So currently there's a lot of changes going on, and we hope by the end of the year that we will kind of start stabilizing and release our 1.0 release candidate 1. And that's the current plan, and then we'll kind of go from there. I didn't know, how much time I had, I had to talk here, so I prepared a tiny little demo. It's very short, and Alex, you let me know if we have time for this or not. But if not, we can do this another time.
I think I'd like to see a demo.
Sure. All right, so now that we talked about our project, I just wanted to show a super simple demo. If you want to run this yourself, you can go to, this is where it is on GitHub. So the idea behind this is I just wanted to show simple orchestration of a couple of services. And one of the things that's nice about declarative languages is that they're very language agnostic. So since we defined, declarative languages in some sort of markup definitions, we can not only have different runtimes in different languages execute them, but also we have the ability, especially also through using some of the standards such as OpenAPI, to define our interactions or workflow with those services in a programming language agnostic way. So in this demo, what I wanted to really show you is we have 3 services, and the one is a Node.js service. All right, and I'll try to ping it here. This one lives on 8080, so we can just, everything is on localhost, but of course you can, run this deploy these functions basically on any environment you want. So you see we ping this Node.js service, and it gives us just invoked our Node.js function. We also have a little Go service that, of course, written in Golang, and that to me is going to run on port 8081, right? So it just gives us the same pretty much thing, just says it was invoked. And in the end, we have a little Java service. And I'll just start it up right now. So you can imagine those being different services that you might want to invoke, and they are part of the execution of your workflow, meaning that your workflow requirements need some information from these services and have to invoke them to maybe provision something or whatever have it. And I'll think our Java service runs at this endpoint on 8083. I think, well, we'll figure it out. No, so I'll figure it out, but 8082, yeah, sorry about that. I have this wrong. All right, so Java service is also up and responding. And now what we want to do is we want to define a simple workflow that kind of orchestrates these services in a very simple way. So I'm going to go ahead and open up VS Code. And we're, in just a couple of minutes, we're going to write our workflow together. So this uses one of the Java implementations, open source there of our specification. As you see, we just have a little Java project, and there is no code. This is just source main resources. We have a couple of files here which are the OpenAPI definitions of our 3 services. So we don't really care where these services are running. In this case, of course, localhost, but we can throw our OpenAPI definitions, define that. So there is no code involved or anything else. So right now we want to start writing our workflow. So let's say we save a new file. We have let's say demo workflow, and we want to define it in JSON format. Now, what we recommend users to do before they start writing these types of workflows is go and get our VS Code plugin. So you can find it here and just go ahead and install it. And that will give you little things like code hints, code completion, and also diagram generation as well. So let's go ahead and define our workflow. Workflow definition usually has a unique identifier. It's called just simple. You can define things like version and things like that. Let's give it a name. And that's pretty much it. The next thing we want to do is tell the workflow, okay, how do you start? And for that, we have a little start parameter, and we can say start orchestration, which is the name of the first, which we call state, but it can be also a step or a task or whatever it's called. Basically, the first decision in our control flow logic that needs to be executed when this workflow instance is invoked, for example. So now the next thing we want to do is define our control flow logic blocks. And for that, we have an array called states. And each state has a name. So in this case, let's say we want our start orchestration state. And each state in our workflow, in our DSL, has a type. So you have a number of different types of states, which all correspond to some sort of control flow logic functionality or block that they perform. So in this case, we want something called an operation state. An operation state is basically a simple state that just does some actions, action being invocation of things like functions, sub workflows, and things like that. So we have then to define the actions that our state wants to execute. And let's start defining that. We have a name, let's say invoke go function. And we give it a function reference of invoke, let's say, go. And that's it. As you see so far, our state definitions are completely domain specific, meaning that you can use your domain specific languages for basically most of the part. And we'll get to the part where that's a little bit different. But for defining the control flow logic, you can fully use your domain specific language. And let's say we also have, we do a copy and paste, and we will invoke after this, let's say our node function. And lastly, we want to invoke our Java function. Let's say in that order, but it doesn't really matter. Another thing that you can specify is the action mode, whether you want to execute these actions in parallel or sequential. For us, we can define this in sequential. And we have to tell our workflow runtimes when to end our workflow execution, and we can end them here as well. So that's pretty much it. Now, I believe that's it for the control flow logic. The only other thing we have to do is we have to tell our runtimes, well, okay, we want to execute these functions that might be living somewhere else or be deployed anywhere really, and be accessed via maybe HTTP or RPC, or we don't really know or really care at this point because we offload that into OpenAPI. So let's give our runtime a little bit of more information of how we want to evoke these functions. So here we have a little function definition. We have to match the name to the function reference. So this function reference, when we come here, we will try to look it up by name into the function definition. And the operation parameter is basically, is currently a path to your OpenAPI definition, which in this case is our Go service, and to the unique operation ID of that particular service, in which case it's Go. And then we can do the same thing for, whoops, I didn't copy it, for our other two. So here we call it invoke node. And here we call it invoke Java. And in this case, we want to use our node service JSON and find out its unique operation ID called node. That's convenient. And here we want to use our Java service OpenAPI definition and call our operation ID of Java. Now, how these functions are invoked, if it's a post or a get, what kind of response we get or not, we all define that with OpenAPI in this case. And that's really it. We have our workflow defined. Now, another thing that you can do is we can preview a diagram within inside VS Code. So you see, we just use plant UML. It's really simple. And it's you know, they're not nearly as pretty as what you guys do at Argo, I must say. But we have a starting state, start of our workflow. We have a single state, which is start orchestration in this case, and it gives you some information and a pretty ugly currently legend that I think with the 0.7 you will be able to turn it off. And that's that. So once we have defined this, we can go back and just start our service. And just making sure that And what this particular Java runtime will do is we'll take our workflow definition, it will parse it into some sort of executable code, in this case Java. It will also expose this service to a API endpoint. So this thing I think already started. I think, hopefully, no, it's still working. I guess it's got to generate a ton of code. All right, it started. And now we have our workflow available as a service. And the endpoint is going to match the ID of our workflow definition. So just I have a little cheat sheet here so I don't have to mess up the curl command. And we can come here and try to invoke our service. Whoops. And I think this is /simple. Oh no, this is simple workflow. So in our case, it has to be simple because that matches our ID of the workflow. All right, and here we go. So what I did now is I executed this curl command to a post request to an endpoint /simple. That is the endpoint that wrapped the execution of our workflow we just defined. And our workflow is basically executed the three functions in the particular order sequentially, stored its responses into our workflow data, and here is the result that you get. So that's kind of like how you can get started with serverless workflow and get up and running with some simple demo. So that's all I had. Again, thank you, Argo. Thanks for having me here and allowing me to talk regarding our project. And if you have any questions, go ahead. And if not, here's some information. We are on CNCF Slack under serverless-workflow. And if you think about any questions or want to, kind of just hang around and talk to us, you're more than welcome. Thank you.
Does anybody have any questions for Tihomir? Tihomir, if people want to find out more, do they go to your Slack channel on CNCF?
Yeah, definitely. Yeah,
cool.
That would be
cool. Okay, I'm going to steal the screen share from you. That's what I'm going to do. Just get the right document. This one. Okay, so if anyone has been in the Slack channels, you're probably aware that we're planning to migrate from our Argo Proj Slack that we have to CNCF, just as a part of our migration to become a CNCF graduated project. We're doing this. We're kind of aware that we're probably going to lose people as a result of this. If people are not, and the people we expect to lose are people actually not really using the Slack channel. And our theory is that the benefit of being able to work better with other communities within CNCF, including things like serverless workflows, will be just very beneficial. Also, we want to take advantage of the fact that the CNCF Slack can keep a much longer history of messages, so we can keep all that information that we currently lose. It says 10,000 messages here, but I think actually it might be like 3 months as well. So we have a number of channels that just don't have any history in them because the last message was sent several months ago. And I think what's not really stated here is a bit of a rationalization of the number of Slack channels that we have. So you can find all information you want to in this particular issue here. There's also kind of a schedule for rolling out. So we'll be archiving, I think, another 4 channels tomorrow, and ultimately a number of other channels will be archived next week. Now, we don't currently plan to replace some of these channels. There's no plan to replace channels such as Random, Argo, Helm, and announcements, or the Argo SIG CI, simply because I personally prefer to have less Slack channels rather than more Slack channels, and that some of those conversations can probably be had within other channels. So for example, if you want to talk about developing for Argo workflows or Argo events, you can jump into their respective channels to have that discussion. Obviously, CNCF comes with its own channels for things like random and announcements, so we don't need to migrate those channels. That's just really an update there. If you do have any questions, come and ask those questions on the GitHub issue here. Just drop in and ask about them. I think we do have some people asking about Argo Helm, so maybe there's a discussion to be had about that in the future. Okay, so that's really all I wanted to say around the CNCF Slack migration. Anybody questions they want to ask now before I reach out to Bala and ask him to take over? Okay, no questions. So Bala's just going to be talking about a couple of features that are probably stated for version 3.2, maybe 3.1. He can pretty clarify if I'm wrong about that, which are two new features called templates, defaults, and the Argo agent. Bala, are you ready to take over?
Yes.
Okay, you have the con.
Yep. Hi, everybody. I'm Bala. I'm a software engineer in Argo team Intuit. Today I'm, okay, sorry. Let me share my screen. Are you guys able to see my screen? Okay, so today I'm going to talk about the two things. One is like 3.1 feature, which is called template default. I'm going to demo that one also. Then second part will be, we are going to discuss about the upcoming feature, the agent feature for 3.2 or 3.1, whenever we didn't target it for 3.1 yet, but if we have a time accomplished, we can include it that feature. Otherwise, it will go into the 3.2 feature. So let me talk about the first part is a template default. So we introduce a new element in the workflow spec level called template defaults, which is mainly the workflow user can define that all the common element for that template element, which can be applied to that all the template in the workflow. For example, retry strategy or timeout or semaphore or mutex and active deadline seconds, all the under the container image pull policy or all the template related, all the element can be defined in the one place called a template default, which will be applied to that all the template in that workflow in the runtime, which is mainly saving the workflow object size. So for example, if you want to put a retest strategy on all the template, it will considerably occupy multiple characters. Then that will automatically increase our workflow object. For example, in Intuit, we have like a 50 steps workflows. If we are adding a retest strategy on the 50 steps, it will be consuming like a considerable amount of object size. That will sometime it will cross that yeah, the Kubernetes size of 1 MB of each object. So that's why this feature is a very valuable for the big workflows whose are commonly define the template common elements. Then that will be applied into the all the templates. So here I have example. I'm defining like the timeouts and retry strategies. And this can be configured in the workflow default in our workflow config map. So that will be applied to that control level config, so that all the workflow will automatically incorporate the template defaults. So that is the next added value we can do that. Let me demo here. So I have a retry strategy of limit 2, and I have the retry failure step. So let me demo that. So I don't have any retry strategy on any steps. If the step is failed, then it's supposed to pick it from the default. See, for example, this is failed, then the retry strategy is picked from the default. It's a good. So now the step level also again start retrying. So now you can see that it is passed. Then it's just going back to just printing that output. So the template default is applied on the runtime for all the templates. Any questions? This is a simple feature.
So
Yes, I had a question. Oh,
yeah, go ahead, Severin.
yeah, thank you. I was just curious if you were to use the template default, in a workflow template or something like that, and then refer to templates from that template, with the template ref, would they continue to have the template defaults that are set in the original manifest?
No. So when you refer a workflow, like when you are using a template ref, then the template default on the workflow template will not be supported. But when you are using a workflow template ref in the workflow template ref, that time the template default will be supported.
I see. Thank you.
Because template ref is like a small function. You are only referring the function, not the whole object, right? So think about that concept. The template ref is like only you are referring the function, not a whole object. So the workflow spec level will not be supported for the template ref, but this entire object will be supported when you are using a workflow template ref, which you are referring that entire object.
Yeah, makes sense.
Any other questions before I'm getting to the next one?
So if I have like an interpolation, a template written into, say, limit there, and it's inputs dot parameters dot limit, will that template value be resolved like per template, or will it throw an error saying, hey, inputs dot whatever doesn't exist at the workflow level?
So you cannot parameterize the template defaults.
Okay, cool.
But if you have a template level retry strategy, that will take a persistence to apply that.
Okay, yeah, that makes sense. So are they completely unparameterizable, i.e. I couldn't even use like a workflow dot parameters?
Yes, workflow dot parameters, definitely you can use it.
Okay, just not template level parameters.
Yes, yes.
Okay.
The
Cool.
global parameter you can use it, because there is another feature we recently merged into master, which will be resolve the workflow level parameter to that all the workflow spec elements.
Nice. Yeah, this is really cool. Thanks.
Okay, let's move on the next one. Mainly next one, our team start working on the agent and HTTP template feature. Mainly the goal was to optimize the execution of the lightweight templates like a HTTP operation, or listing the S3 buckets or something like that. And another goal is like reducing the resource utilization. That means currently that our workflow structure is every step, whether it is a heavy processing or light processing, we need to create a pod, and then the pod will execute the step and finish it. Sometimes the only duration that step will take like a 30 seconds or 1 hour or something. So for example, for the just make a HTTP operation, like invoke a HTTP URL, get the output of the URL, something like that. The creating a pod and image and everything will be like a too much operation overhead. So we were kind of thinking to reduce that one. That's why we introduced that agent concept, which is mainly like whenever the workflow is seeing like a lightweight HTTP kind of templates, which will create the agent pod in the workflow namespace, and it will execute that all the lightweight operations in that template and generate output as a new CRD called a task set CRD. Then the controller will update the output of the HTTP response to the workflow object. So technically speaking, we are creating a one agent will execute that all our lightweight template operations and get the output and update into the workflow object. So the contract between that workflow controller and the agent will be the task set. So task set is very similar to like a workflow, but it's only create and accessible between that workflow controller and the agent, not a user intervention. This is the architecture. So let me go into that, like a real-time user experience on this feature. So currently, if you have like a, if you need to do the HTTP operation to invoke that some URL with a parameter and output the response. So for example, this workflow will have like five elements, five requests you need to make it. In this way, the controller will create like a 5 separate pod and invoke the HTTP request and output the response. But after the agent implementation, it's going to be only one pod, and the workflow looks like this. And we are introducing a new template type called HTTP. Then you can just pause. You can create such a way that it will be executed in the single pod, which is the agent pod, and output will be stored into the workflow template with a different node status. So in the workflow side, there won't be any difference. Only the operation side, the controller will not create a pod for each individual request. It will be executed in the agent pod itself. And I have a little bit detail operation, like what is the controller responsibility and what is the agent responsibility, what are the out of scope for the current MVP, and those all the things here. Like whenever the controller is seeing a first HTTP template in that workflow, then it will create an agent pod on the workflow namespace, and it will create a task set CRD. Then the agent will monitor the task set on the particular namespace, and it will start executing each task and update the output on the task status in the task set CRD. Then the controller will always monitor the task set state change, and if the status is completed, then it will update the output into the workflow status. And once the workflow is completed, then it will clean up that all the informations like agent pod and the task set, and clean up everything and finish the workflow. That's a controller responsibility. Any questions?
Hi, Bala. This is Yuan, and so I see that it's currently only supporting HTTP template. Are we planning to support other types of template, for example, resource templates, so that we can reuse a shared pod to create other custom resources and so on?
Yes, Derry, exactly. So MVP, we are going to support only HTTP, but in future we can support like a resource template, data template, and everything will be more under the agent concept, because those are the lightweight templates.
Sounds good. And how do we handle, for example, for HTTP template, how do we handle any exceptions? Because if it's a script template, we can handle like this in very customized Python script. But if it's just a HTTP URL, then how do we handle different types of exceptions? How do we fall back to different behaviors and so on?
So basically, the the task set CRD will have a status, which is going to have like a what is the HTTP response and what is the error message, and all the things will be stored into that. That will be pass it to the workflow status. And
Okay.
I think we are going to implement a default retry, like something. But I have a question, like still we are discussing like what is the retry strategy for the HTTP template, all the things. But currently we are kind of thinking like if any error is happening on the HTTP request, which will be stored into the task status. Give me a second. Let me show that whatever status. Yeah, here the node result, which is things which will have like what is the error message we got it, and what is the phase, like whether it is success or failure.
Okay, got it. Thanks.
I don't know if you mentioned this, Bala, but there are basically kind of two goals with the agents. One goal is to avoid doing any heavy processing within inside the controller. So the workflow controller can avoid doing heavy processing, which de-risks issues created by workflows, as in, if you've got a multi-tenant system, 2 namespaces, you don't want to do heavy processing for one namespace in case that causes the other namespace any issue. So that moves that heavy processing off the controller into the user's namespace, but it avoids creating it at one pod for every piece of work that needs to be done. So it kind of provides this kind of middle ground between the two of those. And the other kind of benefit that we don't mention is that it means that the agent pod can run with the service account specified by the user, not with the service account specified by the operator for the controller. And that means that the user can protect their data from being read by the controller. So it improves security at the same time. The controller typically can't look at things like contents of secrets and so forth in the user's namespace. So it's actually more secure. And we're hoping that we're going to build it out, I think, as Bala says, for doing HTTP templates, potentially resource templates as well, which are quite expensive to run at the moment. Every resource template comes with a pod that runs for the same for the same life cycle of the resource as well, so it's quite expensive to do. And finally, multi-cluster, multi-namespace workflows, where you have a task within your workflow that runs either in another namespace or another cluster, that moves all the authentication or the security aspects into the user's namespace. So they would then configure, or I mean, it gives us the option to do it rather. Maybe it's actually not quite the right solution for every use case. Gives us the option to put that configuration in the user's namespace. So if you're like us and you're running, hundreds of Argo workflow instances, you don't necessarily want to have to configure every single one of those. You actually much rather have your users configure each one of those instances, so that it'll enable that in the future.
Yeah, better RBAC support.
RBAC is the thing that stops us getting stuff done, I find. A great way to stop you doing some stuff is RBAC. Actually, people really struggle with RBAC. Actually, it's a non-trivial Kubernetes concept that you don't typically want to learn when you get started, but actually often creates a massive roadblock very early on in your development process. Okay, so thank you, Bala, for talking about template defaults in Argo Agent. So those will be coming up in 3.2, and we haven't even put 3.1 GA, so that'll maybe, well, I guess we'll just see where they land. They might land in 3.1, depending what the time frames are. And if you want to learn a bit more about 3.0 and 3.1, we've got a video on the CNCF YouTube channel you can watch. Okay, I think that brings us to the end of our agenda for today. If you have any more information you want to find out, obviously come and find us in the Slack channel, ideally the CNCF Slack channel. And hopefully the video of this will be uploaded onto YouTube later on today or maybe tomorrow, so you can share with your colleagues if they are interested in having a watch of this. Okay, anything else? Any topics people want to discuss before we close out? Cool, great. Well, thank you very much. Have a lovely day.
Thank you, guys.
Thanks.
Thank you,
Thank
guys.
you. Goodbye.